Hi everyone, my name is Ramesh. I am working as an associate professor in the Department of ECE, MLR Institute of Technology. Welcome to the online course on analog circuits. Today we are going to discuss about analysis of transistor amplifier using H-parameter model. In the previous session, we discussed about classification of amplifiers and general H-parameter model for a transistor. In this particular lecture, we discuss about transistor amplifier using H-parameter model. Let us go into the topic. So what we will learn from this particular lecture is about how to derive the current, how to find out current gain, input impedance, voltage gain, output admittance, and power gain of a transistor amplifier circuit. So transistor amplifier, we know amplifier is an electronic circuit which is used to increase the signal strength, and this can be designed with BJT, bipolar junction transistor, and there are three different configurations for BJT: CE, CB, and CC configuration. We discuss about these amplifiers in the coming lectures. Now in this particular video we will do general analysis of a transistor amplifier. So for this amplifier we will consider a source voltage along with source resistance. Let us consider we applied a source AC signal to this transistor amplifier circuit with internal source resistance RS on one side, another side, and the another side is terminated with the load impedance. The load impedance, let us take RL. Now this transistor amplifier is considered as a two-port network. So two-port network, port is nothing but a pair of terminals at which signal may enter or leave the network. If it consisting of two ports, then it is called as a two-port network. Transistor can be modeled as a two-port network, and there are 6 different parameters possible for a two-port network as we discussed earlier. Now in that we will discuss about H parameters, H parameter model of a transistor. For H parameter there are 4 parameters: HI, input impedance, next one is HF, forward current gain, HR, reverse voltage gain, and H0, output admittance. Already we modeled the transistor with H parameter model in the previous lecture. Now again we will discuss the H parameter equations here. The H parameter equations are: the first equation V1 is equal to HI I1 plus HR V2. This is the first equation. The input voltage is a function of input current and output voltage. This is the first equation. And the second equation is I2 is equal to HF I1 plus H0 V2. This is the second equation. The output current is a function of input current and output voltage. These two important equations by which we can model the transistor amplifier. The parameters already we discussed. What is HI? HI is nothing but it is a ratio of input voltage to the input current. And what is HR? HR is nothing but it is a ratio of input voltage to the output voltage, HR. Next one is forward current gain. Forward current gain is defined as the ratio of output current. Output current is nothing but I2 to the input current I1. Next, H0. What is H0? Is output admittance. It is defined as the ratio of output current to the output voltage. Now we have to find out HI, HF, HR, H0, and by which we can find out the current gain, voltage gain, input impedance, and output admittance of a transistor amplifier. Now we will model the transistor amplifier with the given configuration. If you see here, we considered a normal amplifier circuit with VS, RS, internal source resistance, and output is terminated with the load resistor. Now what are the variables of this particular two-port network? The variables are: input variables are V1, I1, and output variables are V2, I2. V1, I1 are called as input voltage and output input current of a transistor amplifier, and the output voltage and output current are V2, I2. Always the currents are considered into the network, but actual current which is flowing to the load, let us consider IL, which is called as load current or output current. But for a two-port network, always the currents are assumed or considered into the network, that is I1 and I2. So with this block diagram and with the input voltage source and load resistor, we form H parameter model of a transistor. Already we discussed about H parameter model by using H parameter equations. Now let us consider the transistor with H parameter model. HI is the input impedance, and we have a source. What is the dependent source here? HR V2 is the dependent source. What is the equation reference for this one? Is V1 is equal to HI I1 plus HR V2 is the reference equation for the input side. Now what is the input current here? Input current is I1, and what is the input voltage? Input voltage is V1, and now at the input side we have an internal source resistance RS along with source voltage Vs. This is the input side circuitry. Now coming to the output side circuitry, we will design this output circuit with the help of output equation. What is the output equation? I2 is equal to HF I1 plus H0 V2. This is the output side equation. This is a KCL equation. The algebraic sum of currents entering the node is equal to the algebraic sum of currents leaving the node. The entering current is I2 and the leaving currents are one. We have a dependent source HFI1. This is the equation. It is depending on the input current and it is a dependent source, that is HFI1 is the dependent source. Now we have output voltage V2, and what is the output admittance? Output admittance is H0. H0 into V2 is another term. Now the incoming current is I2 for this particular node and the outgoing currents are HFI1 and H0 V2. Now as we see in the circuit, the output is terminated. The terminals 2, 2 dash is terminated with the load resistor. The load resistance is RL. Okay. Now the current flowing through the load resistor is IL, and always we consider the currents into the network for a two-port network I1 and I2. And what is the current which is flowing out of the network and which is flowing through the load is called as IL. Now the incoming current IS, source current, is nothing but here the I1 current, because the same current flowing in this particular loop. Now what is the input impedance? ZI. ZI is called as input impedance seen into the transistor amplifier circuit, which is defined as the ratio of input voltage to the input current. What is the input voltage we are applying to the transistor? V1. And what is the input current? I1. Now how can we define the input impedance? It is the ratio of V1 by I1. Now similarly, we need to find out what is the output impedance which is seen into the network, that is Z0, and it is also the ratio of V2 by I2. V2 by I2. And output admittance, how can we define output admittance? Why not? Is the ratio of output current to the output voltage. Now we need to find out the parameters here based on this circuit model. What are the parameters we have to find it here is what is the current gain. So for a particular amplifier, the current gain should be as high as possible. Okay. Now voltage gain is defined as the ratio of output voltage to the input voltage. So we need to get an amplification from the circuitry. So for that, voltage gain should be as high as possible. What is the power gain? Power gain also should be as high as possible for a given ideal amplifier. Input impedance, if you take here, okay, the input impedance should be as high as possible, because why we need to have the input impedance high is there should be a very less drop across this source resistance, and most of the signals should be coming to the transistor amplifier circuit. That's why if the impedance is more, the voltage drop across that particular element will be more. So that's why we input impedance should be high for a ideal voltage amplifier. So ZI should be as high as possible. Now coming to the output admittance. Output admittance is nothing but Y0, which should be as minimum as possible so that impedance is high. When impedance is high, this particular Z0 will be considered as an open circuit. If it is open circuited, the current will be flowing through only the load resistor. In that case, we will get the maximum current and maximum power across the load resistor. Now what are the ideal characteristics we can expect from the transistor amplifier is the current gain should be as high as possible, input impedance should be high, voltage gain should be high, power gain should be high, and output admittance should be as minimum as possible so that output impedance will be high. Now this is the transistor amplifier circuit. Now we will derive one parameter, that is first parameter is current gain. Current gain. How can we define the current gain? So current gain is nothing but it's a ratio of output current to the input current. If you see the circuit, if you see this particular circuit, what is the output current here? IL. And what is the input current coming to the transistor amplifier? I1. Now we need to find out what is the ratio of IL by I1. For that, if you see the relation here for this circuit, IL and I2 are flowing in opposite direction in the same branch. Now IL will be considered as minus I2. IL is equal to, you remember this one, IL is equal to minus I2. Both are flowing in opposite direction. Now what is V2? V2 is nothing but output voltage. How can we define output voltage? By Ohm's law, the current flowing to the load resistor IL into RL is considered as V2. V2 is equal to IL RL. Now coming to the current gain expression here, IL by I1, both are flowing in opposite direction. As I said, IL, instead of IL we can consider minus I2 by I1. Now to derive this particular current gain expression, we need to consider one of the H parameter equation. If you see, V1 is the first equation and second equation is I2 is equal to HFI1 plus H0 V2. If you consider this equation, we can able to find out the current gain. Now the current gain expression, to find out, we need to take second equation. What is the second equation here? HFI1 plus H0 V2. HFI1 plus H0 V2. What is V2? Already we have taken V2 is equal to, what is the expression we got for V2 is IL RL. In place of IL we can consider minus I2 into RL. Minus I2 into RL. Now if you substitute in this particular equation, then I2 is equal to HFI1 plus H0. In place of V2 we can substitute minus I2 into RL. Now this term I'll take it to the left side to get I2 common. So I2 minus, if you take it to the left side, it becomes plus H0 RL I2 is equal to HF I1. Now we can take I2 common here. Okay, if you take I2 common, it becomes 1 plus H0 into RL is equal to HF I1. Now we can take the ratio of I2 by I1 here. I2 by I1 is equal to HF divided by 1 plus H0 into RL. Now this is the expression we got, but what is the current gain expression? Current gain expression is minus I2 by I1. Now we can consider AI is equal to, current gain is equal to minus I2 by I1. Now the expression for the current gain, final expression, so minus I2 by I1 is equal to HF divided by 1 plus H0 into RL. Now the current gain of a particular transistor will be depending on three parameters here. First one is HF, forward current gain, and output admittance, and RL. RL is called as load resistor. Consider this as a first equation. So we derived the equation for the current gain. Next important parameter we need to derive for a transistor amplifier is input impedance. Second one is input impedance. Input impedance is Zi. So let me see the circuit so that you will understand here. Zi. Okay, Zi is nothing but input impedance of the transistor amplifier seen into the network, and it is defined as the ratio of V1 by I1. That is input voltage to the input current. Now for this input impedance, we need to consider the first equation. If you see, we have a relation between V1 and I1 in the first equation. For the input impedance, we will consider Zi is equal to V1 by I1. We will consider the first equation here. V1 is equal to Hi I1 plus HR V2. So this is the first equation of the H parameters. Now V1 is equal to Hi I1 HR V2. So what we can take common here is, if you see, if you divide both sides with I1, now V1 by I1 is equal to Hi plus HR into V2 by I1. Now what is V2? V2 already we have used here. If you see here, V2 is nothing but minus I2 RL. Now we can consider the same equation here. V2 is equal to minus I2 into RL divided by I1. Okay. Now V1 by I1 is considered as input impedance of a transistor amplifier, which is Hi plus HR. Already we know minus I2 by I1. Minus I2 by I1. What is minus I2 by I1 here? It is called as current gain. So we can replace minus I2 by I1 here with AI current gain into RL load resistance. Now what is current gain expression? The current gain expression already we derived. It is minus HF divided by 1 plus H naught into RL. 1 plus H naught into RL. Now the final expression for the input impedance is HI. In place of AI, we can substitute minus HF into HF divided by 1 plus H naught into RL. So then it becomes minus HF HR divided by 1 plus H naught into RL into RL. Now this is the expression. This is the expression for input impedance. Second equation, input impedance is equal to HI minus HF HR divided by 1 plus H naught into RL into RL. Now this particular expressions, whatever we are deriving here, will be equally valid for all the three configurations. What are all the three configurations? CE, CB and CC configurations. Now we are doing general derivations here, and we can apply these derivations part to the CE, CB and CC configuration. Next one is voltage gain. Third one is voltage gain. What is the expression for voltage gain? Voltage gain is nothing but it is defined as the ratio of output voltage to the input voltage. Now voltage gain is equal to, we can write it as output voltage is in terms of, if you see the circuit, output voltage in terms of output current and output resistance. So we can write here V2 is equal to IL into RL divided by V1. Now IL we can instead of IL we can write minus I2 because both are flowing in opposite direction. IL is equal to minus I2. Already we have a current gain expression. What is the current gain expression? Minus I2 by I1. So minus I2, in place of minus I2 we can substitute AI into I1. Okay. So in place of minus I2, what we are going to substitute here is AI into I1. So therefore the expression for voltage gain, becomes AI I1 RL divided by V1, and I am taking this I1 to the denominator. It is AI RL divided by V1 by I1. Already we know the ratio of input voltage to the input current. Input voltage to the input current will be considered as input impedance. So what is the expression? AI RL divided by ZI. Now voltage gain is equal to AI RL divided by ZI. This is the third equation. Okay. In the problems, they will give the four parameters HI, HF, HR and H0. They are asked to find out current gain, input impedance, voltage gain and output admittance of a given amplifier. For that case, first you need to find out what is the current gain, input impedance, then only you can find the voltage gain. Or otherwise you can substitute AI value, which is minus HF by 1 plus H0 into RL, and ZI value already we derived here. ZI is equal to HI minus HF HR RL divided by 1 plus H0 RL, and by substituting that also you can get AV. So instead of that, first find the current gain, input impedance, then you can find out the voltage gain very easily. Now we derived the three parameters, and let me move on to the last one, that is output impedance. Output impedance, or to get the output impedance, first we need to find out what is output admittance. What is output admittance? It is the ratio of output current to the output voltage. By considering the input side voltage is equal to 0. Why we are considering the input side voltage is equal to 0? Let me go on to the circuit and understand how to find out the output admittance and output impedance. Okay. So see this circuit. To find out the output impedance, first we need to find out what is output admittance. Output admittance is the ratio of I2 by V2. Now what we do in Thevenin's equivalent circuits to find out a particular impedance or admittance, by open circuiting these terminals and nullify the effect of sources. What is the source here? What is the source? The source is Vs, and we nullify the effect of this source. Vs will be equal to 0, and this I2 by Y0 is equal to I2 by V2 Vs is equal to 0. At Vs is equal to 0, we are finding Y0, and from Y0 we will get Z0. Z0 is nothing but 1 by Y0. So see here, we are nullifying the effect of sources. Vs is equal to 0, and for this case we need to take the second equation of the H parameters, that is I2 is equal to HF I1 plus H0 V2. We have to take this equation. From this equation and divide both sides with V2. I2 by V2 is equal to HF into I1 by V2. V2 by V2 cancels out, it is H0. Okay. Now I2 by V2 is nothing but it's a ratio of output current to the output voltage. First we will find output admittance. After that we will find out what is Z0, input impedance. Okay. Now this is called as output admittance. First we are finding what is the output admittance of a given transistor amplifier. I2 by V2 is considered as Y0 is equal to H0 plus HF into I1 by V2. So this we are taking at Vs is equal to 0. Now this is a relation between input current and output voltage. For that we need to take the circuit. So what is the circuit here? The circuit, input side circuit is Rs, and input impedance is Hi, and input side dependent source we have HR into V2, and we will take Vs is equal to 0. Vs voltage is equal to 0 means the logical representation is short circuit. Vs is equal to 0, and already considered the current I1. Okay. Now apply the KVL to this particular loop. Entering terminal is positive and leaving terminal is negative. Here also entering terminal is positive and leaving terminal is negative. Now what is the expression by KVL we will be getting here? Minus, entering terminal means positive, means it is minus Rs plus Hi into, because both are in series, Rs plus Hi, both are impedances in series, Rs plus Hi into I1. This is also positive terminal entering, minus HR into V2 is equal to 0. Now from this equation what we can write here, Rs plus Hi into I1 is equal to, I am taking this to the right side, it becomes minus HR into V2. Okay. Now I1 by V2 is equal to minus HR divided by Rs plus Hi. Now we got the expression for I1 by V2, which is minus HR divided by Rs plus Hi. This particular equation we will substitute in Y0. Y0 is equal to H0 plus HF into I1 by V2. So in this equation we will substitute Y0 is equal to H0. See here, H0 plus HF. What we got for I1 by V2 here, minus HR by Rs plus Hi. Minus HR by Rs plus Hi. Now so Y0 is equal to H0 minus HF HR divided by Rs plus Hi. This is the expression for output admittance. So we got 4 parameters. Now the fifth one is the power gain. Power gain is defined as the ratio of output power to the input power, that is P2 by P1 or P0 by Pi, output power to the input power. So output power is in terms of output voltage and output current. What is the output voltage? V2, and output current is IL. And what is the input voltage? V1, and input current is I1. Now we know V2 by V1. V2 by V1 is nothing but it is considered as a voltage gain. What is IL by I1? It is considered as a current gain. Now the power gain is expressed as product of voltage gain and current gain. If voltage and current gain is more, the power gain of the particular transistor amplifier will be more. Now we know what is AV, voltage gain. We can write it as AI RL divided by ZI AI. Therefore power gain is equal to AI square RL divided by ZI. This is the expression for power gain. Now we derived all the parameters here: input impedance, voltage gain, current gain, and output impedance. Let me go on to the summary here. First one is current gain. The expression for the current gain is minus HF divided by 1 plus H0 into RL. And the next one is input impedance, which is HI minus HF HR divided by 1 plus H0 into RL into RL. And the third one voltage gain. The voltage gain expression is AI into RL divided by ZI. And the fourth one is Y naught is equal to H naught minus HFHR divided by RS plus HI. And the next one is power gain. Power gain is AI square RL divided by ZI. Now, in this session, what we learn about transistor amplifier using H parameter model. In the next session, we will discuss about the analysis of CE amplifier using H parameter model. Thank you for watching the video.